here, this is the thing on the internal status indicators. And this just tells you what they are. At one place in the manual they had, maybe they took that out. It showed different indicators being out. And I mean, all that was just generic information. They took that out. I think that's good. If you look at the older manual, it has this little grid in it here. And this, in all honesty, this was made up by some engineer guy that was probably reading this out of a book. And most of these scenarios you'll never see anyway, okay? So as far as I'm concerned, for us guys out in the field that's trying to get through this and troubleshoot, this information right here is probably worthless. But you know what to do when you see a light out as far as chasing that down. This will identify the power sources for you. And most of the time, the instruction is going to say you replace the computer anyway, okay? Let me show you something else in this manual that may scare you. Oops. Oh, hell, I don't have the manual up anymore. If you look at the error codes in the manual, they list every single possible error code in there. And chances are most of those error codes have never been used. There is analog faults, and you might get a B fault once in a while, or maybe a C8 or a C16. Most of the fault codes you see out there have never been seen on this computer, and they all say replace the computer. And it's just kind of scary when you look at that and you think, what the hell have I gotten into here, right? But don't let those error codes scare you, because most of those have never been seen. Your general faults here, your A, B, C, and D faults, are still the same as they were with the old 400 system. The analog faults are A's, the internal function and power feeds are the B's. Internal memory faults are the C's. And then the D is a miscellaneous or chart code selection, okay? Now, note the little note there at the bottom that you'll always investigate faults in the B and C groups before you go to the A groups, because chances are that's heading towards a computer replacement. If you have an honest-to-God memory fault in there, like a C16, I mean, that computer can be condemned right on the spot because you aren't going to fix it in the field. If it has a C8, you may be able to erase the data and get it to working. Okay? A D, that's going to be fixed along with the analog fault. Most of the faults you'll see on this system are going to be analog, somewhere between A01 and A12 or 13. Okay? That'll be mostly what you'll see. B faults, a B16 is a fault that once in a while you'll see a short in the function kickout system will cause a B fault. Here we are back at the job of the reeling drum. Remember I told you this was the same for all systems that use this reeling drum. The purpose and the setup of this reeling drum never changes, whether you're working with a big RT or you're working with a little boom truck or a little Broderson carry deck machine or whatever. This reeling drum stays the same. The color codes are the same, the voltage are the same. Everything about that is the same, okay? That even includes the new Insight and the Element. You know, they use the same reeling drum. So I'm going to kind of skip through this a little bit and preserve our time. Did anybody have any questions about the two-block system? You all okay with that? The voltage system? How to check it out using your cards. So we go right to the RCI 510 calibration procedure. And this is kind of a unique procedure, and it's gonna require inputs from you. It's gonna require you to put some thinking into it, maybe even some measuring into it, whatever you need to do. But this talks a little bit about why we zero and span, because we need to educate the computers to where to start calculating and where to quit. So the menus used in the setup calibration, now this goes along with what we call the fast calibration setup, because you're only going to use certain functions out of this menu. There's a lot of functions in this menu that you don't use in the normal mode, but they leave them in there, okay? So looking at this guide, this tells you exactly what sensors we're going to use. Menu number 2 for zeroing sensors, menu number 3 for span sensors, and menu number 4 for swing pot calibration. Okay? These are the only menus we're going to use to make changes with. If you try to do a radius moment with this, it's going to come back at you and say there's no EEPROM, and it's not going to let you do it anyway. Okay, so there's a lot of functions in there that you can't get into that are set by the software. They're hard-coded into the software. I thought I gave that to you yesterday. I didn't. So, again, in order to calibrate the system, we got to have that unit set up safely on nice level ground, and outriggers fully set. You know, I'm not are any of you certified operators? No? I'm not a certified operator myself, and usually when I go on a job site, I grab me an operator and I make the operator set that crane up in a safe position if I'm going to operate it myself. Because a lot of times you want to operate it yourself to do your troubleshooting work. If I'm doing a calibration on it, I want an operator up there operating it where I can man the tape measure myself and see what's going on out there. So, a lot of times I'll carry in fact most of the time, I'll carry an extra long extension cable for the display, and I will put that display down on the bed of the crane I'm working on and monitor all that stuff myself and use an operator so I don't have to think about the safety operation portion of the crane, you know. So that usually works out pretty good. The owners are usually pretty good about furnishing that. So entering the calibration mode on the RCI 510, a little different from the 586, and there's a little more to it. And it has a special key sequence that you use, and a special key sequence you use to initiate that calibration mode. In setting up this sequence, you have exactly 5 seconds to put in the right sequence of keys, or it'll go right back to the operate mode. It won't let you in, okay? So in order to initiate this calibration operation, you will press the test button and the set button together and hold them until it says enter the correct key sequence. Okay, you can jump start these and just hit them and just start typing stuff in. It really doesn't work well that way. You need to take your time, hold the keys down until it asks you for the sequence, and then press your key sequence in. And this is usually intimidating to people, believe it or not. It's just a little upper left, lower right, lower left, upper right sequence, but it usually comes up as pretty intimidating for people that's trying to do it in front of other people. So this is a good thing for you to practice on the simulator while you're here and get to where you know that sequence and the feel of it. Because once you do it and get the feel of it, it's no longer intimidating. You know, you can. I've had guys on the phone that had to take like 4 or 5 tries before they could get it in there right. You know, so you need to get with that key sequence up here. Make sure that you can enter into calibration mode on there. The first thing that I start doing, if I'm working with somebody on troubleshooting something in the calibration over the phone, I'm gonna ask you to get into calibration mode. Okay, I want you to give me the duty file number and some things like that, and start running you through some exercises. So this is a good thing to learn, is this key sequence. Make sure that you know it. Once you get into the calibration mode, it's going to come up in the error codes mode, okay? Now, here's a little helpful hint. Sometimes you get a situation, say a bad swing caught, that's got a bad spot in it or something, and you're trying to track this down, but the error code is so fleeting you can't read it, okay? It blinks in and out so quick, you lose the error code. If you go into the calibration mode and go into this error code mode here, this will hold the error codes on the screen for you, okay? It will be held on there all the time. You can do your rotation thing and pick up that error code, because you can stop in time to get it. That, I've always found that really helpful, okay? Also, in this error code screen, notice here, it has the duty file number. This is a D510-300, which just to me says, okay, this is an RT230. Okay, so I know what I'm working on. So that's the kind of information I may be asking you for. This serial number is the serial number of the computer that was burnt in during the calibration. Okay? We didn't ask for that on the older machines as much as we do the newer ones, because we track this stuff very closely by serial numbers today. So we are getting more and more demanding about asking for serial numbers of the computers, so we can go back and pull records on them while we're working with you. Okay? So the duty file, the serial number is important. Any error codes you have are important, because we can quickly spot a sequence of events here and help you set up a reasonable troubleshooting scenario. So, in preparation for zero of the extension sensor, notice that this is, I think that's probably copied right off the 586, okay? Because this extension procedure is exactly the same, other than the fact you're going to enter in your span numbers, okay? So the first thing we're going to want to do is go in and retract the boom all the way, rotate the extension sensor to the right till it stops, come back and get our half turn. And if we have the bucket job, we may want to get into taking voltage readings, okay? If we have any doubts about voltages. And then bring that sensor back a half a turn to set up for the calibration. Same thing in preparation of the angle, of the zero of the angle sensor. Same preparations. We're going to bring the boom to perfect zero on the level. And we're going to probably check our voltage on that, unless I'm real confident that it's okay. I may stick a voltmeter in there and check that, because that's important. So we're going to find that 0.475 volts there. On the zero for the extension, notice we use the menu up and down keys here to go up and down in the menus. And we're going to go into O2, which is always zero of the sensors, no matter what system you're working on. O2 is always sensors, zero in your sensors. Sensor O2 is always extension. Okay, so see, we start up here, we menu up till we get to the O2 zero sensors menu, and then we go into that menu, press this upper right key here, and it will take you into that menu, and it will default to zero number 2, which is always extension, okay? So we have our zero number 2 equals some number, and pressing that upper right key will zero the sensor and give us our starting point. Same way for angle. If we set our level on top of the boom and get the boom perfectly level, when we go into zero sensor number 3, which is right under the extension menu, it's gonna have some kind of a number reading in there, and pressing that upper right button will force the system to agree with the level. It's like this, 0 equals 0, okay? So in spanning the sensors, we always become aware of overhead obstacles, checking for overhead obstacles and stability issues. Go into those routines. And span the angle. You know, a good thing to remember, if you're calibrating one of these, like an RT or a truck crane, it's a lot easier if you do these functions 2 at once at the same time, and saves time. This is the way that you calibrate one of these units in about a half hour. After we set the zeros, we just raise that boom up to 60 to 65 degrees on our level, and we read the numbers off the level for angle span, and we subtract the extended, the retracted length from the extended length, and get us a span number, which we're going to type into the software. Does everybody understand how you get the span number? Just taking your retracted length, your pin-to-pin retracted length, from the pin-to-pin extended length. And the number you get, the result, is the span number, which will go into the software. So, entering a span in the calibration is really an easy chore. We have a special screen that you go in for entering numbers. We go on to the spanning routine, which is it's menu number 3. And of course, this always defaults to extension, to sensor number 2. And then when you want to go to sensor number 3 and span, you just hit the menu up button, and it'll take you to span number 3. Once you need to remember that too, because once you get into the menu, it's not going to tell you again what menu you're in. It's just going to give you an entry screen like this, okay? That's happened to me. You get in there and you forget where you were, somebody interrupts you or something, and you're thinking, oh shit, was that on the extension or angle, you know? If you do, hit something and start over. It's user friendly, okay? You're not going to screw it up. So, finalizing this number entry in the spans, you're going to, once you hit the calibrate button, it's going to come up with this screen, and you're going to enter some numbers for these spans. Either this particular one, I think, is for angle. And you're going to use the bottom 2 keys to go find the number. It'll put the number in the little brackets. Once you find the right number that you want, you hit the upper left key, and it will store that number in the brackets over here, one number at a time. And you want to make sure you enter a decimal. Want to make sure you enter the decimal. Once you enter this number and hit the upper right key and calibrate it, you'll see that extended length come up into this window. It'll show you the proper extended length or the proper angle, whichever you're setting. So you see how you get to that? It's very easy. And it's fast too. We can go through this very fast. So we're going to take the swing. We're going to swing that around into the house lock position and throw the house lock. Go into menu number 4 for swing potentiometer. With it locked into position, we're going to 0 that. You want to make sure that you use the house lock if it's available and get this position accurate, because once you set this 0, if you move like 0.2 degrees in either direction on a pick and carry, it will throw you off the chart. Okay, so the pick and carries are meant to be done with the house lock thrown or the thing on a perfect 0. Now, Unlike the old 400 systems where you had to do all these rotations and these antics and stuff, with this 500 system, all the information is already there. All you have to do is go in and set your zero position. And then we like to have you pick up the boom after you zero it and rotate to the right and set that where the numbers count up. Rotating to the right, numbers should count up. And it's not that the system won't work like that, it just gives a consistency to the system when you go using the operator alarms and stuff, so that it's always counting up, okay? If it is going the wrong direction, if you just hit the menu up button, it'll take you to another menu that says direction, and it'll have a plus or minus there. And if you hit that key, you hit the calibrate key, it will change the plus to a minus or the minus to a plus, whichever applies, okay? Basically, all that is the communication wires on the swing pot. You're actually switching them in the software rather than physically switching them, okay? So that's what that's for. That being done, you can move on from there and go into the checking of the calibration. Get your tape measure out and check several different points. You know, when I check the calibration, what I like to do is take and use at least 3 points on the boom extension and 3 angles, and just measure some radiuses and do some compares with the display. And you can allow a ½ a foot over on radius or plus 10% on the load. If you're out of those tolerances, you need to take a serious look at what's going on there, because there's probably something wrong with your calibration. One time I was up working at Terex doing some calibrations, and we kept getting these sloppy calibration results, and come to find out their level was off 2 degrees. So it was really throwing a kink in the radius. So this is really important when you get done with these calibrations, that you get that tape measure out and throw it on there. And it just takes a few minutes, and run through a few of these steps and record them. You know, get you a piece of paper and record down what your display says and what your tape measure says, and then you can put a plan of action to fix it, whatever the problem is with the calibration. If you don't do it that way, the bad problems only get worse. You know, the way to correct it is measuring things. Any questions on that? All right. Now, let me go over this with you just a little bit. The notorious RT1120. How many ever heard of an RT1120? Ever seen one? Okay. This is a special machine that Terex came up with that has this synchronous extension with a CAN bus system on the old 510 display. It uses 3 reels on it, has a whole bunch of sensors out here at the boom tip, and a CAN bus system that records all this. And to tell the truth, the system is really about 80% Terex and about 20% Greer. And us in the office really never got a chance to get hands-on these and learn that much about them. So usually I refer people to Grady Singleton out at Terex here in Wilmington in order to help people get through this system. I don't try to do it myself because I don't have enough experience at it. But in this PowerPoint, Scott Macon down here in Texas had a lot of those machines. So I threw in this school specifically for them on purpose, so they would have some kind of information. And this has some background on the components. It also has Terex information about selecting the modes and so forth and working with that part of it. So if you get into one of these machines, I would advise you very first thing off to get in touch with Terex and let them give you some guidance on testing it out and troubleshooting it, because it does get pretty complicated. It has an OEM control system in it, which regulates a lot of the functioning of the crane through their computer, their OEM computer. And that's the reason that gets complicated like that. So, I mean, at least there's some information for you on it. And if you get a hold of Grady, Grady is the master on that system, he can guide you right through it.